That's 0. So you see the 2 works, and you check that the 4 also works. Just for my curiosity, when is the velocity 0? Oh, that's easy. That's when this equation is 0, so that's when t equals 3. What is at that moment the position? Oh, I substitute t equals 3 in here, and that gives me -1. X equals -1. So now I'm ready to plot x as a function of t. It's of course a parabola, and I use this information that we have just derived. So here comes my plot. Let this be increasing value of x. Let this be 8. And let this be -1. This is the time axis. I have a 0 here. And so I want to cover, let's say, about 6 seconds. So I have 1, 2, 3, 4, 5, 6. Now I'm going to use this information in order to give you a curve which is similar to that one, except this is a simple one. This is just a parabola. So I know that at time t equals 0, the object is at position 8. I know that x is 0. That x is 0 at the time 2 and at the time 4. So the object is here at this time and at this time. And I know that at time t equals 3, it is at position -1. So the object is here. And I also know that the velocity is 0. So we can check that. And so if I make this plot now, then we would get a curve that's sort of like this. And yes, indeed, notice the velocity here is 0. The angle alpha equals 0. The object starts out at t equals 0 with a negative velocity. You can see that. The object at t equals 0 is here. This is where the object is. I hope you realize that. The object is never here. This is the road. This is the one-dimensional track on which the object is sitting. The object is here, and it starts going in this direction. If it starts going in this direction, the velocity must be less than 0. And indeed it is. It's -6. But there is the acceleration, which is +2. It's in this direction. The acceleration says, I don't want you to go down. I want you to go up. Well, the velocity says, sorry, all I can do is slowly change, and that's what it's doing. It's slowly changing the velocity, and there comes a time that the velocity is 0. So the object goes down, the velocity changes, and when it is at position -1, it has come to a grinding halt, and now it is returning. This positive value of a is now increasing the velocity, and that's what you see. I therefore bet you a nickel that if you substitute in that equation t equals 4, that the velocity better be positive. It has changed from a minus sign to a plus sign because of this positive acceleration. I bet you a nickel. T equals 4. What is x? What is v? We want to know v. 8 minus 6 plus 2 meters per second. You see, physics works. V is now plus 2 meters per second. So all that information is in there, but I want you to be able to also digest it. Don't look at that curve as just some dumb parabola, some dumb curve. Try to imagine what is happening. And only then do you get some insight. Then you really begin to get it in your brains. I now would like to write down, in most general form, the equation for the position and the velocity as a function of time for a one-dimensional motion whereby the acceleration is constant. So it's going to be one-dimensional again, and we have a is going to be a constant. And so the equation that I write down is the most general way that I can write it down. So we're going to get x equals some number c1 plus some c2 times t plus some c3 times t squared. And notice, oh, I already erased my example. My example is gone. But you would have seen this was an 8 before. And here we had, what did we have? We had minus 6t and we had plus 1t squared. So you recognize these three. I can now take the derivative. And so I get c2 plus 2c3 times t. And then I get the acceleration equals 2c3. And now we get some insight into these quantities. Clearly, x1, c1, is the position of x at time t equals 0, for which we often write an x0. Because when t is 0, that is where x is. c2 is really the velocity at time t equals 0, because when t is 0, that's when c2 is v. And the acceleration is not changing with time, is 2c3, therefore c3 is half the acceleration. So this gives you some insight in the meaning of these quantities, and you can see, you can read now some physics in there. C1, C2, and C3 can independently be either 0, or larger than 0, or negative. Makes no difference. Each one of these combinations is a valid possibility in physics. When we have gravity, an object is influenced by the gravitational acceleration. And the gravitational acceleration is a constant. And we write often for that gravitational acceleration the letter g. Whether I drop an object, or throw it vertically up, or I throw it vertically down, it's all one-dimensional. It becomes two-dimensional when I throw it at an angle. I keep it one-dimensional. The acceleration is always the same. And that g, gravitational acceleration, in Boston is 9.80 meters per second square, and it varies a little bit for different places on Earth. This gravitational acceleration is independent of the mass of the object that I drop, of the speed of the object, of the chemical composition of the object, of the size of the object, and of the shape of the object, assuming that we have no air drag, assuming that these experiments are done in vacuum. Is it obvious that the gravitational acceleration is independent of all these quantities? By no means. Is it true? We think so. But I want you to appreciate that it is not obvious and it cannot be proven from first principle. Remember last time we dropped an apple from 3 meters and we dropped another one from 1.5 meters. And in your second assignment, which you haven't seen yet, I'm asking you to calculate the gravitational acceleration for me using these both experiments. And of course, I want you to also tell me what the uncertainty is in your final answer. And I'd like to help you a little bit to set it up and also to get these equations in terms of gravity. Whenever we deal with gravity, we get the g in there. So suppose here is the object at time t equals 0. It was the apple, and I call that position x0, I call that 0. I'm free to choose my 0 position, and I drop it at 0 speed. I just let it go, because that's the way we did it in class. The object goes down, zzz, and it hits the floor. Well, the general equations now, which deal in gravity, if I call this the increasing value of x, you can choose it differently. This is my choice today, is the following. X equals x0 plus v0t plus 1/2 gt squared. And g now is 9.80 meters per second square. The velocity at any moment in time equals v0 plus